In this question, this is the experiment related to the rate of the cooling, as I mentioned. The general procedure is the same, and we will just modify our procedure according to the objective. A student suggests that the area of the water surface will affect the rate of a cooling of a hot water. That's student suggestion. Like student is saying, if we change the area, the cooling of the water will, of a hot water will change. It will affect. We have to plan an experiment to investigate the relation between the surface area and the rate of the cooling. Now in this experiment, we cannot keep the surface area constant because that is our experiment, that is the objective, that we want to investigate how the surface area is affecting the rate of the cooling. We have to write a plan. Whenever you write an experiment, you always try to answer the points. Don't try to write paragraphs. You try to answer each point separately so that you don't miss a single thing in the experiment. So first thing, they asked the apparatus needed. What apparatus we need for this experiment? So we need a thermometer, we need a stopwatch, we need 2, or we can also say 3 different containers. One with a big surface area, another one is a large surface area. That's good. So what we need? To investigate the rate of the cooling, how the rate of the cooling is affected by the surface area. So the apparatus we need thermometer, we need a stopwatch, we need 2 different containers, or you can mention 3 different containers, like one is big, one is small, and another one is in between, or a moderate, in between the two, like not too big, not too small. So we need different containers. One is big, one other is large, and there's also a supply of hot water. But even like in this one, even you write thermometer, stopwatch, and container, you will score the marks. So that is the first thing. How would you obtain a range of surface area? How will you obtain a range of surface areas? Like how you get different types of surface areas? So how we obtain a range of surface areas? So we'll take a beaker or a container with different widths, this different circumference. So actually, what is written at the top in the apparatus, like 2 different containers. So here we'll take containers with different base areas. As the containers will have different base area, they will have a different surface area. Like you take a small beaker, you take a large beaker, they will have a different surface areas as well. If I take a small beaker, it will have a small surface area. If I take a large beaker, it will have a large surface area, large base area, so it will have a large surface area as well. So take container or beaker with different base areas. Instruction to carry out the experiment. How we do this experiment? How we carry out this experiment? So what we will do? We will pour the hot water in, for example, the small container. Then record the temperature. Then we'll start the timer or the stopwatch, and we'll record the temperature for 3 minutes with the 30-second interval. And then we'll repeat with the large container. Repeat the same procedure with the large container. So this is the answer for the third one. So first, what apparatus needed, then how we obtain different surface area, Then how we carry out the investigation. The measurement you will take. So what quantities, what measurements we are taking? We are measuring a time and temperature. Don't write temperature as TEMP, write as full. Because of the space I'm writing it's TEMP, but in exam you should write full temperature, the complete. Yeah, that's right. Repeat the experiment is very good term, which we always do. Like repeat the experiment for a small container for 2 times or 3 times, or then repeat with a large container. The precaution you will take to ensure that the results are reliable. Like what precaution we should take? So because whenever you're using a thermometer, you should look perpendicular, avoid parallax error. Then what else? The thermometer bulb should not touch the base of the container. Should not touch the container. And we should use the same starting temperature. Why it should not touch the base of a container? Because the container temperature might be different from the liquid temperature. Like a container, it might be a copper container or a glass container. So this temperature of a container is not necessarily same as the temperature of the liquid. They may have different temperatures. So the thermometer should not touch the base of the container. If it's touching the base of a container, the bulb of a thermometer touching the base, this is not the accurate. This won't be accurate. So it should be above. To clamp the precaution we can take, we should clamp the thermometer. So it should not touch the base. Yeah, we should keep the type of a container in this experiment. We should take the same type of a container, same amount of the water or the liquid used. So same amount of the liquid used. Same starting temperature for the. Then the graph you will plot from your results. So here you should sketch the axis with appropriate. In this experiment, they did not ask for the variables which must be kept constant. That's why I added in a precaution. They did not ask for what variables must be kept constant. They just asked what are the precautions. So precautions, these are the precautions: avoid a parallax error, and it should not touch the base of container. These are the precautions. Same amount of the water and the same starting temperature are the variable which must be kept constant for a fair comparison. And then you don't have to plot a graph, you just have to sketch the axis. When you sketch, label the axis, it should be with the appropriate unit. So time is there in second and temperature is there in degree centigrade. That's it. So a diagram is not required, but you may. Whenever a question is there, you may draw a diagram. I advise that you should draw a diagram. Why? Because maybe your explanation might not be complete. So you will score the mark from your diagram. So you may draw a diagram. You should consider that it is compulsory, even though it's an optional here, but you should consider that it's a compulsory and you should include a diagram. In case if you miss any point in the explanation, you will score the mark from your diagram. Is it clear? This experiment investigating how the surface area can affect the rate of a cooling of a hot water. I will show you the I'll show you the marking scheme points as well, like how the marks are distributed. The next slide is having the marking scheme. So Apparatus, different size beaker, thermometer, stopwatch, you score mark. Method, you pour hot water into a container, you measure the temperature and time and repeat for a second container with a different surface area. Precaution, here in a precautions, they mention any two from this. So you take a same volume, you took same initial temperature, and like additional points are there. Write any one from this, take same amount of the water or same type of a container, and then you plot a graph between the temperature and the time. So about, they did not mention here about the thermometer is touching the base of a container or looking perpendicular, but don't forget to mention them in a precaution, as this was the early question. Like in 2016, the precaution, they were used to write precaution in a precaution these things. But 2016 onward, 17, 18, the precautions were not acceptable when you write volume of the water or initial temperature. The precautions were thermometer should not touch the base of a container or you should look perpendicular. So this was one of the experiment. There's another experiment. The new student is investigating what is the effect of the insulation on the rate of the cooling. What is the meaning of insulation? Like we have a container and we surround this container by any material which does not allow the heat to escape. That is known as an insulation. Yeah, the rate of the cooling will decrease as it does not allow the heat to escape. A student can choose from the following apparatus. Student is having a thermometer, is having a 250 cm cube glass beaker, a 250 cm cube plastic beaker, 250 cm cube copper can, 250 cm cube measuring cylinder, 3 different insulating material, a clamp box and stand for the thermometer to clamp, and a stopwatch. So one is we need thermometer and stopwatch and a clamp. These are compulsory for all. And 3 different insulation. Now I'm left with 4 different types of container. Which container is the most suitable for this experiment? Which one you think is the most suitable for the experiment? I can select any of them. Yeah, which one you think will the most suitable? So the most suitable is a glass. Why we select glass? Why not plastic? Why not copper can? Why not measuring cylinder? Look, why we did not select plastic? Because plastic is itself is insulator. So it won't be accurate because so why we did not select a plastic? Because the plastic is insulator. So we are already providing an insulating material. So then what is the use of having a plastic container, plastic beaker? Why not copper? Because copper is a conductor. So it will allow the heat energy to transfer easily from the water. So it won't be that effective. Glass is intermediate, like it conducts some, not too much. It's a poor conductor. So that's why the most appropriate is a glass. And why not measuring cylinder? Because measuring cylinder is having a small surface area. So the rate of the cooling is also affected by the surface area. That's why we did not prefer to use a measuring cylinder. So we prefer to use a glass beaker. The question is, plan an experiment to investigate the effectiveness of the three insulating material. Explain how would you carry out the investigation? How will do this experiment? How to carry out the investigation? It is same like the previous experiment. So I'm writing it here because of the space. So we'll take a glass beaker and we'll pour hot water, record the initial temperature or the starting temperature, and we take a glass beaker, we pour hot water, and we'll place insulation material 1 or A around the beaker. And after that, we'll record the starting temperature. After recording the starting temperature, we'll start the timer or the stopwatch and record the temperature for like 3 minutes with the 30-second interval. Then we'll repeat with 2 other insulations. The same procedure, we repeat with the 2 other insulations. So this is how the experiment is carried out. This part is there. What key variables that you should control? It's a plural, so you have to write like 2 or more. What we should control?
Starting temperature.
The starting temperature, that's right. Your question is, what if we do the experiment with all beakers? No, it won't be effective. Why it won't be effective? Because we may have a different surface area for these beakers. Like a 250 measuring cylinder won't, you have to keep the same type of a beaker for all the 3 insulation. If you change the type of a beaker, you will lose the mark. That is the most important thing, that keeping the type of a container or a beaker same. So the starting temperature is 1. What else?
Surface area of container.
Yeah, surface area, or you can also mention take same type of a container throughout the experiment. Same container or same surface area should be there for all the experiment. And amount of the volume of the liquid or volume of the water. Surrounding temperature, temperature of the lab or the room. And the thickness of insulation. So the thickness of the insulation should also be same. Don't mention these points like same stopwatch and same thermometer. Practically, it's not having any effect. Practically, I will tell you the reason is that if I use my stopwatch or my friend's stopwatch, it does not make difference to the experiment. Then draw a table or the table with a column heading. So that's how you present your result. So you don't have to write any values. You just have to complete. Time is there and the temperature for 3 different insulating material. So, and table should always be with a column heading. So time in second, temperature in degrees centigrade, temperature in degrees centigrade, and temperature. And that is for insulating material A, insulating material B, and insulating material C. Time column you can fill. It's not necessary. If you draw the table, that is fine. Time you can fill as you mentioned, like we record with a 30-second interval. So 0 will be there, 30 will be there, 60 will be there, 90, 120, 150, and 180. So you can it's up to you. You can mention the time. Temperature, you don't have to mention anything as you're not doing the experiment. Or even this table you draw without writing any time interval, that's also fine. You will score the mark. So this is the table which you draw to present our data. How would you use your reading to reach a conclusion? So how we reach our conclusion, so we'll plot a graph between the time and temperature and compare the gradient. And we'll compare the gradient or the slope, the one which is less steeper or the one which is greater slope or steeper, or the smaller slope shows smaller rate of cooling, or it will be effective insulation. So the one which is having a smaller slope will have a smaller rate of the cooling. So example, if you sketch a graph between the temperature on y-axis and the time on x-axis. For these, like example, this is a result, say this is a sketch. This is for A. And this is for A. And say this one is for B. So which one is steeper, greater angle? Which one is having a greater angle? So A is steeper. So A is having a greater angle. So A is steeper than B. So it means A is having a faster cooling. So it is not effective insulation. B is less steeper, means the angle is small. So it means it has a slow cooling. So it means that is a good insulation, because if it's a good insulation, does not allow the heat energy to escape. Is it clear about this?
Yes, sir, clear.
Anyone having a doubt? Any doubt or a question in this experiment? Okay. Then the marking scheme points. What are the marking scheme points? Like how you score the marks, the distribution of the mark. 1 mark, as I mentioned in the beginning, you should use same container throughout. So if you use same container throughout, you will score 1 mark. Then the procedure, the second mark, when you mention pour a hot water in a container, you take a temperature at time interval and start, and after a fixed time, that like the procedure is having one, then repeat the experiment with different insulation. That is the 3rd mark. Then 4th and 5th mark is depending on the variable which you keep constant. You mention say either any 2 of them. You mention same room temperature, same starting temperature, you will score the mark, or same volume or same thickness of the insulation. The table with a appropriate column heading, you will score a mark. And then use a reading or a graph between time and temperature and compare the result. How you compare the result? The best insulation which has a smaller drop, and its opposite, the one which is steeper will have a faster rate of the cooling. So that's how the marks are distributed for this experiment.